Hi guys, day 4 notes. We're going to be talking about solving absolute value equations. Before we get right into that, I actually want to start with a warm-up question just because I think it's important to do another one similar to what we did the other day with factoring. So the directions to factor completely. All right, in parentheses, 4x squared minus 21 quantity squared. Oops, I know it's a little blurry. Hopefully you can see pretty well. I'll zoom in a little bit. And then minus 2 times 4x squared minus 21, and then minus 8. All right. So my hopes is that you immediately look at this and go, same expression in parentheses in 2 spots. We're going to use a dummy variable. So you want to pick another variable to represent that expression for x squared minus 21. I'm going to pick y. Feel free to pause the video, try it, and then turn it back on and check the solution. So your steps. Rewrite it. So this is going to be just simply y squared minus 2 times y minus 8. Now we can factor it. So when we factor, oops, just a touch off the screen there. There we go. When we factor it, this is now just trinomial factoring. So y, and then we're going to go minus 4 and plus 2. When you sub back in, then it's going to be 4x squared minus 21 minus 4, and then 4x squared minus 21 plus 2. Now you could put the parentheses in, but I think since it's at the front of the parentheses, you can see it's not going to make much of a difference here. So now just combine your like terms. So when we do a little cleanup, if you will, this becomes 4x squared minus 25. This becomes 4x squared and then minus, let's see, 19. All right, from here, 19, that's prime. It's not really allowing us to go any further. But here, that's difference of perfect squares. So this can break into 2x and 2x plus 5 and minus 5. And then we're just simply going to keep that 4x squared minus 19. That is as far as this can break down. So if you tried it on your own and you got it at least to here, that's awesome. Recognize that you want to make sure that you clean it up because then sometimes you can see that it can keep going. All right. The focus of today's notes, solving absolute value equations. Absolute value is something you should have seen in Algebra 1, or maybe you even did some graphing with it. We're going to spend 2 days on this. Today, we're going to talk mostly about the algebraic, even though we are going to briefly look at the graph. And then tomorrow's notes, or day 5's notes, will focus on solving graphically. So the reason I bring up the solving algebraically, solving graphically, even though we're going to focus on algebraic today, is because it kind of tells us like what can happen, all right? So to solve absolute value equations, we want to make sure we remember what that even looks like. So you can use plain old regular notation or function notation, doesn't matter. So I'm going to say y equals absolute value of x. So it's those 2 vertical bars around it. Now by definition, what does an absolute value mean? Well, I always just think of it as it makes the number positive, but you can't really write that out in an easy way. So what I want to think of it as, I'm going to use a little curly brackets here, is if the value inside is already positive, so if x is greater than or equal to 0, that value is going to stay the same. So absolute value of 5 would stay 5. If the value on the inside is less than 0 or negative, then it's going to switch the sign. So to switch the sign, it'll be equal to negative x. Because like if this was -2, if I do negative of -2, that becomes positive 2. All right, that double negative cancels. Graphically, you might remember what this graph looks like. It looks like the V. If you want to, you can do it on your graphing calculator really quick just to see it. Otherwise, we'll focus on that with the lesson tomorrow. But draw yourself a quick set of axes. It's going to look like that perfect diagonal line right here, and then right here where it's reflected over that y-axis. That is our y equals absolute value of x. So keep that visual in mind. And I want to talk about 3 quick scenarios before we move on to the algebraic solutions. Oops. See if I can get all this on the screen at once. All right. So 3 quick little examples. The first one, if I said, let's solve for when the absolute value of x is equal to 3, and let's think about it graphically. Graphically, we know what that looks like. That's the v right there. Think about what 3 itself looks like. If I just said graph y equals 3. So essentially think about if this was like y1 and that's y2. I'd have that V shape, and then y equals 3 would just be a horizontal line that cuts through it. So what I would end up with would be a little graph that kind of looks like this. Here's my V, and then I would have this cutting through at 3. And so how does that help me? Well, to figure out where they're equal is literally where the graphs cross. So it would be a solution here, and it'd be a solution right here. And you might even know, okay, well, if I put 3 in, it comes out as 3. If I put negative 3 in, it would come out as 3. So those would be my 2 solutions. That's kind of my key takeaway here, that there are 2 solutions, and it would be negative 3 and 3. Right? The second example I want you to think about, see if I can squeeze it in under here, would be, what if we said solve for when absolute value of x equals 0? All right, well, the first part of the graph wouldn't change at all. You'd still be thinking about, all right, I get that V shape. So I'd still have this. What about the second piece of it? Y equals 0. That's that horizontal line that actually is the x-axis. So where do they cross? Well, just in that one spot right there. So I would have just one little solution. And specifically, it'd be when x is 0 itself. So if I plug 0 in, that's it. All right. So 2 solutions, 1 solution. What I want you to think about is, what could we set the absolute value of x equal to that would produce no solution? So think about horizontal line going from here down to here. If I can get it to shift any lower, so like -2, something like that, then I'm going to get a graph where I've got this V shape here and then a horizontal line that cuts through here and never intersects it. So that's where I would end up with no solution. Right? So I bring this up because as we solve them algebraically, you're going to see sometimes we're going to get 2 solutions. Sometimes we're going to get 1 solution. Sometimes we end up with no solutions at all. All right. So those are the things that can happen. All right. With that being said, let's go ahead. I'm going to flip my page here, and let's actually try some solving just algebraically and not thinking about the graphs at this point. So I want to do the first example where we kind of do the example and we write the notes as we go. Let me see if I can zoom in a little bit for you guys. I think that'll work. All right. So to solve absolute value equations algebraically. Whew, that's a mouthful. All right. For our first example, give yourself the absolute value of 3x and then plus 2 equals 8. Over here, I'm going to write down what are the steps that we want to be able to do to solve this. So the first thing I always want to do is, as best you can, I want you to isolate the absolute value. So step number 1 is to isolate the absolute value. And we're going to see some examples when we go to do like the homework or the practice where you can't totally isolate it, but enough that it'll work. But we'll talk about that later. So in this case, that simply just means, all right, let's move that 2. So we get absolute value of 3x and then equals 6. All right. From here, this is where the definition comes in. The absolute value, if the value inside is positive, it would stay positive. If it's negative, it's going to switch signs. So you have to consider 2 equations. And how I want you to make 2 equations here, me kind of show you what I mean, is let's make it kind of generic. If we say the absolute value of, whatever this little star is equals A, one equation is that you're going to drop the absolute value bars, leave it exactly as is, set it equal to A. The other thing you're going to do is you're going to take the bars off and you're going to set it equal to the opposite of A. All right, so the value inside is either positive A or negative A. But once you take the absolute value, it will come out to be that value right there. Technically, you can actually negate the star in this scenario or the A. It doesn't really matter, but just want to negate one of them. I usually find at the beginning it's easier to negate the outside part. So in this case, let's break it up. Drop the bars, set it equal to positive 6. Drop the bars, set it equal to negative 6. And then solve. So step 3 is just going to be solve both equations. So divide by 3, we get 2, we get negative 2. All right, last step. Oh, it's always my least favorite, but you do have to check the answers. Some equations, you can just assume that they're going to, work out, and the answer you get, unless you made a mistake, is going to be the answer. But with these ones, you may need to reject a solution, all right? So when you check it, you need to make sure that you plug into the original equation. That is key, all right? The one that has the absolute value in it still. So when I say let's check, let's take the 2. If we go into 3 times 2, take the absolute value, add 2, does it equal 8? So this would be 6. Absolute value of 6 is 6. Add 2, yep, we're good to go. So that answer is good. Now check the other one. So absolute value of 3 times negative 2, add 2 to it, will that equal 8? All right, well, this is going to give me negative 6, but when I take the absolute value of negative 6, that comes out to be positive 6. Add 2, we're still good to go. So both of those answers are keepers. So 2 and negative 2, easy, done. You know that that's not always going to be the case, or I wouldn't mention it. So let's try the next one and see how it goes. So for the second example here, oops, I'm going to give you 3 times, oops, there we go, the absolute value of 4x minus 5 minus 2, and then equals 19. All right. Look through those steps as you go. First step says get the absolute value alone. So I want to get rid of this minus 2 here. I want to get rid of the 3 in front if it's possible. Following the kind of almost like a reverse order of operations, let's move the 2 over first. So add that on over. We get 21. And then 3 divides nicely out, so let's divide that out. Once we get the absolute value completely alone, then you split it. So not until that happens do you split it. Okay. So drop the bars. 4x minus 5 equals positive 7. Drop the bars. 4x minus 5 equals negative 7. Because if you stop and think, if this whole thing equals 7, yep, you're good. If this whole thing equals negative 7, absolute value will still come out to be 7. That's why we do this. All right. Just solve them from here. Add 5 over. That'll give you 12. Divide by 4. We get 3. Play the same game over here. Add 5 over. That's going to give us negative 2. Divide by 4. That's going to give us negative 1/2. All right. And then you have to check. So when you go through and check, use that original equation. So 3 and then the absolute value of 4 times 3 minus 5 minus 2 equals 19. Right? So this will give you 12 minus 5, or 7. And then remember, you have to take the absolute value. So absolute value of 7 is 7. So 3 times 7 is going to be 21 minus 2. we get 19 equals 19, and you're good, all right? So make sure it works. Don't just put a check sign and be like, yep, I'm happy. Make sure it actually works, all right? Same thing over here. If we do 3 times the absolute value of 4 times negative a half, and then subtract 5. If you need your calculator to assist you with some of the calculations, do it. It's perfectly fine, right? So this would give us negative 2. Negative 2 minus 5 is negative 7, but then you're going to take the absolute value. So the absolute value is plain old 7. So again, I get 21 minus 2 is 19, and we're good to go. So both of those answers work. So far we've seen 2 examples where the answers both check out. So it might feel like, well, why are you making me do this then? All right, little hint. You got one more to go here so that you can see where maybe it's worth it to actually do it. All right, let's flip it here so we got a little more space. Last example of the notes. Dun, 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 dun. All right. We've got negative 5 times the absolute value of x plus 1 plus 2 equals 12. Okay. Get it written down. Pause me anytime you need to. Rewatch anytime you need to. Let's go. Get that absolute value alone. So subtract 2. So we get negative 5 times the absolute value of x plus 1 equals 10. Divide by negative 5. We get absolute value of x plus 1 equals negative 2. Now split it. Drop the bars. X plus 1 equals negative 2. X plus 1 equals positive 2. All right. When we solve, subtract 1, we get negative 3. Subtract 1, we get 1. All right. Now here comes the check. So if we plug in negative 3 into the original, we get negative 3 plus 1 on the inside, which is negative 2. Now take the absolute value of that. So the absolute value of negative 2 is just 2. But then it's negative 5 times that. So that becomes negative 10. Add 2 to it, and we get negative 8 equals 12. When we get 2 values that don't match, that's where we're going to reject that answer. All right? Play the game over here. It's negative 5 times 1 plus 1, and then plus 2, and then equals 12. All right, we get negative 5 times the absolute value of 2, which is 2 all by itself, and then you get negative 10 again. So we end up with that same weird result. And so when both answers reject, here's where we end up with the no solution. The key is that when it's a no solution problem, there typically was a clue where we could have figured out that it wasn't going to happen. If one solution rejects, you can't usually see that coming. But if no solutions happen, if you backtrack in our work here, this line right here is where the issue occurs. The fact that we have an absolute value set equal to a negative number, that's never going to happen. The lowest value you're ever going to get would be a 0 when you take the absolute value of something. So if you end up with an absolute value equal to a negative somewhere in your work, you can stop right here and then go to no solution, because this can never happen. All right, there you go. I'll see you guys soon.